Afternoon or morning, whichever it is for you, third grade mathematicians. We are going to get to work on area and perimeter, and we are with the same learning goal. Guess what? I didn't put it on our slide today. Oh, yeah, there it is. Okay, so still area and perimeter. We, as mathematicians, will understand that area and perimeter are attributes of plane figures. To be successful today, you're going to be able to compare rectangles using what you know about area and perimeter. So when you go to the third grade math slide today, this is the video you're watching right now. Now, this is what we're going to do today. You're going to be asked to compare rectangles by creating them. Rectangles with perimeter of 14 inches. So as we know already, the perimeter is the measurement all the way around the length of all the sides. So length of two adjacent sides. So I need to create as many, your directions are going to be, create as many different shapes of rectangles as you can with the perimeter of 14. So here's where your number sense comes in. And I'm just going to start with 1 because it's easier for me to go in numerical order. So if I have, I'm going to go back to the big screen. If I have my rectangle and this first side is 1, I know the other parallel measurement is 1. So if I'm trying to get a rectangle with the perimeter of, was it 16? 14. So I'm going to think of, now what would be the measurement of this side? And really it has to be a number that if I double it, it's going to be 2 less. So I've got 1, 2, so I have to get up to the number of 12. So I know 6 plus 6 is 12, 13, 14. So do I have a rectangle with the perimeter of 14 units? I didn't give it a measurement. I'm changing my marker because I can't see this. Let's give this centimeter. I think that's what we're looking for. So this first rectangle that I made is this length and this length is 6 centimeters, 1 centimeter. So if I added it all up, 1 plus 6 is 7, plus 1 is 8, plus 6 is 14. Got it. And I'm going to fix that. Now I'm going to try to find another rectangle shape. So the shape doesn't matter as much as what we're trying to find is the measurement. So I'm going to go and try combinations of numbers with this measurement of 2. What I did want to point out is when it says the word adjacent, that's a mathematical term that means this side with the 1 is adjacent to 6. So perpendicular is also kind of a word that we've seen. So there's this 1 is adjacent to 6. 2 plus 2 is 4. So I'm trying to get a total measurement perimeter of 14. So if I take 4 away from 14, what do I end up with? 10, that's right. So now what's half of 10? Because I have 2 sides. Half of 10 is 5. I always encourage you to check your math to make sure that it's adding up. 2 plus 5 is 7. I have 2 more sides. 7 plus 7 is 14. All right, we're doing it. I'm going to try to see if there's another combination if I use 3. 3 plus 3 is 6. So if I went over here, 14 minus 6, that's 8. What's half of 8? 4. So let's see if this is working out. 3 plus 4 is 7, plus 3 is 10, plus 4 is 14. We did it. So here are 3 shapes with the perimeter of 14 centimeters. How do I know though when I'm done? Are there any other possibilities of shapes? I'm going to try 4 because look at the pattern. I like to stay organized. 1, 2, 3. So then the next side measurement would be 4. Well, that's duplicating that. The other side would be 3. So let's try 5. 5. This would be 5. That'd be 10. Oh, 11, 12, 13, 14. Oh, see, we already did it. So these are the 3 shapes that give us that perimeter 14. Let's go back to our worksheet now. This is what you'll be doing on your paper when you get to your homework, and then you're going to enter the data on a table, like a T-chart. So this is how you're going to complete the table on your homework. Length of 2 adjacent sides. I'm going to list 1 centimeter and 6 centimeter. That's my 2 sides. And it'll look like this: 1 centimeter, scoot over, 6 centimeters. Ooh, now I have to calculate the area? Oh my goodness. So area is the space inside, length times width. Length times width. 6 times 1 is 6. 6 centimeters. I have also some props here, just to clarify again what area is. I made some examples. Here's a rectangle, and what area means is how many squares could I put in this inside of the shape? That's what area means. So area is the space inside, length times width. Length 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4, 5. 8 times 5 is 40. So there are 40 squares put inside of this shape, boys and girls. That's what that means. I actually happened to measure these out to be 1 inch. So this in particular example is 40 square inches. This is another example, different shape, and this example is 8 across, 2 down. So 8 times 2 is 16. 16 square inches is the area for this shape. Here's one more. 4 across times 3 down. There should be 12 squares in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So area is the space inside, which means how many squares can you fit in that shape? I hope that helps, boys and girls. So let's go back to our table. So we have the 1 by 6 centimeters rectangle. Now I'm going to put on the chart 2 adjacent to 5. 2 centimeters, I'm labeling my answers, and 5 centimeters. And so then I have to calculate the area as the space inside, length times width. 2 times 5 times 2 is 10. Uh-oh, who saw the mistake I made up here? I hope you did. Square centimeters, Miss Doyle, because that's how many squares fit inside that shape. Then our last shape that we found, a rectangle, is 3 centimeters and 4 centimeters, the adjacent measurement, 3 centimeters and 4 centimeters. So I hope you're yelling out the area of this. 3 times 4 is, thank you for the help, 12 square centimeters. Great. That's what you're going to do today. So this is what your assignment looks like when you go to Google Classroom. This is the video again in case you needed to replay it. Here's your directions for today. Follow these slides in order. On a piece of paper, solve each problem. I solved each problem on a piece of paper. Drawing the shape. A, label it. Find the length of the adjacent sides as well as the area. We need both. You will type in your answers on the worksheet on slides 5 and 6. So here we go. Here's one of 2 pages of the worksheet. So you're going to draw out, it says centimeter on a centimeter dot grid. Don't worry about that, boys and girls, because you don't need it. Just draw out your rectangle and label the sides. You're going to find the information. Please don't try to type into this slide. This is a challenge for me to get students to follow the directions. You're just going to solve it on paper. And then you go to this slide. Hey, there's a table. This is where you answer the questions. Here's the length of the 2 adjacent sides and the area. Here's number 3, because back up here at this one slide, compare the shapes of the rectangles with the least and greatest areas. This is where it's deeper thinking. If you get stuck, you're welcome to ask me, but it's saying what's different. You're going to have the same perimeter. Why do they all have a different area? We practiced that yesterday too. The next slide is problems 4 through 6. Same thing. Draw out your rectangle. This one is now you're making the rectangles based on the area. This is when your multiplication facts for 16 really comes into play. 1 times 16, 2 times 8, 4 times 4. There's your hint. And then you enter your information here, lengths of the adjacent sides and what the perimeter is. Label your answers, and here's where you type in your response to comparing the shapes. Okay. I hope that you're getting a real strong understanding of area and perimeter. We've worked a lot on this, and we're going to move into more challenging comparisons as soon as you have a better idea and understanding of perimeter and area. And we're almost there. I'm proud of all the work you're doing. Check in with me if you have any need for help. Have a great day.